All right, we're about to cross the finish line. We're on to the last part of our Caesar Cipher, and we're going to complete it in this lesson. First, go ahead and fork your own copy of part 4 of the Caesar Cipher starting code. And notice, firstly, we've got an extra file here called art. And this, if you expand it fully, you should see an ASCII art of our logo. Now, what we want to be able to do in this lesson is just to tidy up some of the loose ends, improve the user experience, and fix some of the bugs that you may or may not be aware of. To do number 1 tells us to import and print the logo from art.py, and this is going to show up when we first load up our program, like this. Next, we're going to tackle this one. One of the things we haven't really thought about is if the user enters a shift number that's actually really, really large, like 100, then we're actually going to run out of letters in our alphabet. And so we're going to use what you've learned before, and it might take a little bit of thinking around this to fix this particular bug right here. And once you've done that, then we move on to over here, and we think about what to do if the user wanted to type a number, a symbol, or a space. So we want to preserve the symbol, space, or number that they typed in. And we're only going to use our cipher on the rest of the message. So only the alphabetical letters. And everything else we're going to leave the same. So for example, if we had the text, meet me at 3, then the end text will keep the spaces where they were, keep the numbers where they were, and also if there were any symbols, we would also keep that in our final end text. And it's only the letters which will get scrambled. And then finally, to do number 4, we're going to figure out how to ask the user if they want to restart the cipher program. So notice how in the final version, when we've run this once, we can actually type yes to go again. This way we can keep encoding and decoding as much as we want until we're actually done, when we can type no and it says goodbye, and that's the end of the code. What we want to be able to do is, instead of having to run our code again and again, we're going to figure out a way of getting our code to be rerun if the user typed yes to this question. And if they typed no, then and only then do we actually end the program. It might take a little bit of thinking to figure out how to solve all of these to-dos, but once you're ready, and if you're up for the challenge, then pause the video now and give it a go. All right, so let's tackle them one by one. The first one you've already done before. All it needs is to import the art file. And if we want to be able to use the logo variable inside the art file, this one, then we can also simply just write from art import logo. So now we can print this logo right here. So that's to-do number 1 completed. Now let's do the next one. This one requires us to figure out some sort of clever solution so that when a user enters a shift that's greater than the number of letters in the alphabet, over here, we have some sort of way of getting it back within the range of 0 to 25. And I want you to see what happens when I type a message and I put a shift that's really large. You can see we get an index out of range error, because there is no letter at position 77 from the alphabet. So that's why this line 14 over here actually breaks down. If you had trouble with this, I gave you a hint where I wanted you to think about how you can use the modulus. Say if we said 45 divided by 25, then it would give us the remainder. So 25 goes into 45 once, and then we have a remainder of 20. So that is what this would equal. 45 modulus 25 would actually give us the output of 20. effectively, what I'm asking you to do is, even if a user gave us a number that's too large, say 45, we're going to subtract 25 from it, or as many 25s as we need, so that we get it within the range of 0 to 25. And the code that achieves this is simply changing the shift from the one that the user inputted into a version where we use the modulus. Now, if we run our code again, then you can see that no matter how long my shift is, I'm going to use 87, we end up with the result. It's like as if we took 87 and we divided it by 25, and we can see that there's 3 25s in 87. 87 minus 75 gives us 12. And that means the shift is equal to 12. If this is at all confusing, I really recommend to print out what shift was equal to before we did this manipulation, and then to print it out after we've done that. And this way you can see how we're actually manipulating that shift number so that we end up with a shift that fits in to that range between 0 to 25 so that our code doesn't actually break. And once you're done, let's move on to do number 3. So here we want to be able to allow any number, symbol, or space, basically anything that's not within the alphabet, to go through and end up in the end text. But if it is one of the letters inside this list alphabet, then and only then do we actually want to do the shifting and encoding. In order to achieve this, we should probably use an if statement to say if the character. So notice how I've changed the for loop to, instead of writing for letter in start text, which kind of assumes that everything in the start text is a letter, to char, which stands for character instead. Because a character could be a number, could be a symbol, could be a letter, could be space. And then once we get hold of the char or the character, we're going to check to see if the char is in the alphabet. So if it is indeed one of these letters and not some other random character, well then and only then do we actually want this code to be executed. So let me just make sure all the indentation is correct. And if it's not inside the alphabet, so else, well then in this case we actually want to make the end text append the actual character, so without any modification. Now, if we test this code by running it, so let's go ahead and encode, and I'm going to encode something like hello, 1, 2, 3, some symbols, a space, 3, 2, 1, and now when I hit enter and I give it a shift, then you can see that the encoded result has all the letters, all the things that are in that list, the alphabet, encoded. But everything else, the numbers and the symbols, are all left as they are. Because more often than not, your user might want to write a message like meet me at 5 or something exclamation mark. And this is just a very simple way of making it work. Now, of course, there's a lot of other ways that you could have solved this. So you could have, in fact, added a whole bunch of symbols and numbers and space and other characters to this list. And instead of calling it alphabet, it could have been the characters list. And then you could have encoded all of that. But that's actually not what the to-do asks for. It wants us to let through the numbers, symbols, space, and only encode the letters. So now all we have left is the last to do. And this is probably going to be the most difficult one out of the lot. What we want to do here is we want to be able to ask the user whether if they want to go again. So whether if they want to encode or decode another message. And what happens in the final version, the completed version of the app, is if we encode a message and we get the result back it doesn't just end, it doesn't exit, because otherwise you would see that message down here, run again. Instead, it continues and it asks us, well, do you want to go again? So we could write yes, and it lets us again encode or decode a message. We can basically go on and on and on and repeating this program until we want to exit. And it's at that point when we can no longer type anything into our program and our code ends, and we'd have to run the whole thing again in order to use it again. So at the moment, the part of our code that actually needs to be repeated if the user wanted to restart it is actually just this part. So the first thing I'm going to do is I'm actually going to shrink it down a bit. So where we've got all this print code from previously, where we were trying to figure out how this worked, I'm going to get rid of that. And now all we're left with is 1, 2, 3, 4, 5 lines of code, which needs to repeat if we're going to get the user to reuse the Caesar Cipher. What if we go ahead and indent this and put it inside a while loop? What are we going to check to make sure that our loop continues? Well, we could create a flag called should continue. And we start this out to be true. And then while this is still true, we continue to keep looping through this so that the user gets to input a new direction, new text, new shift, and call the Caesar Cipher on that again. When should we stop it though? Well, if at the end of deciphering or encoding their message, we ask them a question, something like type yes if you want to go again, or type no if you don't want to, we could put that inside an input, like so. And we can save their answer inside a variable. Let's just call that result. So now we can use an if statement to check, well, if the result is equal to no, so when they actually want to stop and they want to exit the while loop, well, at this point, we can switch that should continue to false. And once that's done, then this means that this while loop, when it checks it, this is going to be false and it will no longer continue. Just as a final touch, we can even tell the user goodbye so that they know that the program has ended. Now let's go ahead and run our code and see if it works. All right, so let's first encode something. And now I can type yes to go again. And you can see it's allowing me to type encode or decode. So let's encode something else. Now, finally, if I decided I've had enough, I'm done with encoding and decoding, I'm going to type no, it tells me goodbye, and I can now see my prompt, which means it's actually exited out of the program, and I would need to run it again in order to restart it. Did you manage to get that right? If you want to take a look at the completed code, then you can head over to Caesar Cipher for end, and you will find the same code as I've got here. And of course, feel free to play around with the code, modify it, and make this program your own. So if you wanted to add some extra features, if you wanted to make sure that the numbers and symbols are all being encrypted, add any sort of bells and whistles and anything else that you can think of, this is the time to do it now. But once you're done, be sure to get some rest, because tomorrow is yet another packed session where we're going to talk more about Python dictionaries. For all of that and more, I bid you good night, and I'll see you tomorrow.